In this lesson, we are going to be using the fundamental theorem of algebra. We will ask that you find all zeros of a function and also to be able to write an equation when you are given the zeros of a function. So in review, let's find all the zeros of this function. So first we want to find all the possible zeros. So the possible zeros for this function would be all the factors of our constant term, making sure our function is in standard form, divided by the factors of our leading coefficient. So we would have plus or minus 1 as factors of 15, plus or minus 3, plus or minus 5, and plus or minus 15. And since our leading coefficient is 1, these would all be divided by 1. So here's our complete list of all of our possible functions. Now the next step that we determined when we worked before was that we needed to put this function into our graphing calculator and to estimate one of the roots so that we could use synthetic division. So if you put this into the graphing calculator, you would see that -3 is one of our possible roots. So using synthetic division, writing out our coefficients of our function, when we bring down the 1, we multiply, add the 2 together, we multiply, we add the 2 together and we multiply, and that is one of our zeros. So then we can rewrite that function in a quadratic. So we have x squared minus 2x plus 5 is equal to 0. And notice that there are not two values that I can multiply together that give me 5 that have a sum of -2. So we need to use the quadratic formula to finish solving. So x will equal to plus or minus the square root of -2 squared minus 4 times a times c, all divided by 2 times a. So we have x is equal to 2 plus or minus, and if we take a look, this is going to be -2 squared will be 4 minus 20. So 4 minus 20 is going to give us -16 divided by 2. That equals 2 plus or minus, remember the square root of 16 is 4 and the square root of -1 would be I. So we have 2 plus or minus 4i divided by 2. So as we finish simplifying, we have x is equal to 1 plus or minus 2i. And that would be the other two roots or zeros of my polynomial function. So one thing that we want to stress is that imaginary or complex conjugates always occur in pairs. So you notice you have 1 plus 2i and 1 minus 2i. That's always going to be true when we are finding zeros or roots of our functions. So the fundamental theorem of algebra simply means this, that we take a look at our function when written in standard form, we find its degree, and it tells us how many solutions that there will be for that particular function. And we've talked about that before, but we just didn't name it. So we are going to now reverse what we've been doing the last little while. We're actually now going to give you the zeros and ask you to write the polynomial function for those solutions. So here's what we do. We need to work in reverse. First of all, we know that there are 3 solutions, and so therefore when we rewrite these as a polynomial, we know that it's going to be to the 3rd degree. It could be even to a higher degree because some of these may actually be double roots, but we are asked to write the polynomial of the least degree. So if there are 3 roots or 3 zeros, we will go to the 3rd degree, and we want the leading coefficient to be 1. So here's what we do. We simply reverse our thinking. So if x is equal to 1, then we reverse that by subtracting 1 from both sides, and we have one of our factors is going to be x minus 1. Again, x equals -4, so to reverse that we add 4 to both sides, and then one of our factors then will be x plus 4. And if x is equal to 5, we're going to reverse that. And then, as x is equal to 5, we reverse and find our factor by subtracting 5 from both sides. So we have x minus 5. And we set that equal to 0. So to find the polynomial, we simply multiply these out. Remember, we are going to multiply only 2 at a time. So if I FOIL these, I have x squared plus 4x minus x minus 4. And when I simplify that quadratic, I have x squared plus 3x minus 4, and I want to now multiply that by x minus 5. So then I'll have x cubed minus 5x squared plus 3x squared minus 15x minus 4x plus 20 is equal to 0. And combining like terms, I have x cubed minus 2x squared minus 19x plus 20 is equal to 0. And that will be my polynomial function having zeros or solutions of 1, -4, and 5. Now, that takes a little while to multiply all that out. So we do have a shortcut that we can use that some of you already do use when you FOIL, and that is this. When you are given 2 roots of a quadratic function, the equation can be determined by squaring the x's, then you subtract the sum, and then add on the product. Well, I do that anyway already. So if I add, for example, if we're doing x minus 1 and x plus 4, I already know that x times x will be x squared. And then in my head, which some of you already do, -1 and 4 would be a positive 3x, and then the product, -1 times 4 is -4. So some of you might already be doing that. It's not too bad when you have those types of roots, but it could be really helpful to use that shortcut when you have your imaginary or complex conjugates. Let's give you an example of that on the next one. So, write a polynomial function of the least degree that has real coefficients, a leading coefficient of 1, and the roots will be 1, -2 plus I, and -2 minus I. So let's use the shortcut, and this is how it works. First, we're going to take the sum of these 2 zeros. We're going to add them together. So we have -2 plus I and -2 minus I. So if I add those together, I and -I will have a sum of 0, so my sum will be -4. And then I want to find my product. So when I find my product of those two and multiply them together, I have -2 plus I, and I have -2 minus I. So -2 times -2 is 4. And then we have -2 times -I would be positive 2I. And then I times -2 will be minus 2I. And then I times -I will be -I squared. Some of you already knew that this middle term would have a sum of 0. Remember that I squared is -1. So if I'm going to subtract -1, that means I'm going to add 1. So my product will be 5. So when I write my quadratic using these two pieces of information, if you recall from the previous pattern, it said take the x squared. And if you look back, then you were supposed to subtract the sum and add the product. So we're subtracting -4, which will mean +4, and then add the product, which would be 5. That's the shortcut. Now I wrote the whole thing out for you, but you could do a lot of that in your head as long as you are comfortable with it, or just multiply it out. Then you have our last root that we need to multiply on. So if x equals 1, subtracting 1 from both sides, our other zero factor would be x minus 1. Then we're going to multiply this out. So we have x to the third power minus x squared plus 4x minus 4 plus 5x minus 5. So we have x cubed, and we have we have minus x squared, and then this was supposed to be plus 4x squared. So that gives me a positive 3x squared. And then we had a positive 5x, and I think I missed my x right here, so it'd be minus 4x, so that's going to be plus x. And then we have minus 5, and that's going to be our polynomial function. Since there are 3 roots, this will be to the third power. Our leading coefficient is 1, and it is the least degree. Let's take a look at another example. So we have 3 roots listed, but if you recall from our first slide, we said anytime you have an imaginary or complex conjugate, we have to have both positive and negative. So because only the 3i is listed, we also know that there is a 4th root, which is positive 3i, because they have to occur in pairs. They always will. So now in this case, we have 4 zeros. So our final answer is going to be to the 4th degree using the least degree. Again, it could be larger than that because some of these could double up, but we want the least degree, which would be to the 4th degree, or an exponent of 4 with a leading coefficient of 1. So we're going to take a look at finding our polynomial function. So let's take a look at these first 2 zeros or solutions. So we could quickly write our quadratic function by either taking x minus 2 times x minus 3, or knowing that the sum of these two is 5 and the product is 6. So using our shortcut, remember we square the x, we have x squared, we subtract the sum, and we add the product. A quick shortcut way for multiplying those out. Then we could do the same thing with these two imaginary. We would take the sum, so when we add them together, negative 3i plus 3i is equal to 0. And when we find the product, we multiply the two together. That would be negative 3i times 3i. Negative 3 times positive 3 is negative 9, and then we have I squared. But if you remember, I squared is negative 1, so negative 1 times negative 9 would be 9. So our next quadratic would be x squared. We subtract the sum, so minus 0, and we add the product, which would be 9. And then all we need to do is multiply these two together. So x squared times x squared would be x to the 4th, times 9 would be 9x squared. Then we have negative 5x times x squared would be negative 5x cubed, times 9 would be negative 45x, and then we have 6x squared, and we have 54. So when we combine like terms, we have x to the fourth, and then we have negative 5x cubed. 9x squared and 6x squared would be positive 15x squared. And then we have negative 45x plus 54. And that's going to be our polynomial function of least degree. Because there were 4 roots, it's to the 4th power. It is written in standard form and has a leading coefficient of 1. To review, first you're going to find all the possible zeros of a polynomial function and use synthetic division to find the zeros. Use your zeros to write your polynomial function, but please remember that your imaginary or complex conjugates always occur in pairs. There is the root theorem, which gives you the shortcut of being able to write the quadratic function by taking the x squared minus the sum of the x's plus the product. And please remember to complete the reflection.